Okay, so here's problem 4 for the CV in 3256 Construction Engineering course, Exam 1. On this one, we're looking at compacting the soil. We're given most of the information here in this actual problem set. Right here, up above, will give us only information on the dimensions when we come to that. So some of the important information for us to look at here that we're going to need is, well, first let's look at the equation that we're going to be using. So going to the equation sheet, looking at the compaction here, here's our equation. It is basically compaction production rate in compacted cubic yards per hour is WSLE over N times 16.3, where W is the width of the roller pass, S is the speed, L is the compacted lift thickness, E is the efficiency, and N is the number of roller passes required. So with that in mind, let's find all of these variables. So if we have one roller taking 4 passes, so there's our N, average speed, there's our S, compacted lift thickness of 6 inches, compacted width of the roller is 8 feet, that's our W, and here's our E, 15 minutes per hour. So what is the expected cost and duration of the operation? So, and this is important here too, so total volume compacted is going to be the product of the non-excavation site area and the lift thickness, ignoring certain things. So coming back up here, it says the entire site is 440 by 300 and the excavation is 100 by 120. So the land around the perimeter of the excavation must be compacted to a depth of 6 inches. So this information will be important for us, not that one, here in a minute. So let's get started. First thing is, let's go ahead and find this compaction production here, this compaction rate. Okay, and it'd be nice for us to have this handy. So, using our equation, is equal to W S L E over N times 16.3, knowing that our W is 8, our S is 8, L is 6, and E is 50 over 60, N is 4, we can just plug all those values in. So 8 feet, feet times the speed of 8 miles per hour times the lift thickness of 6 inches times an efficiency of 50 over 60 divided by lift thickness, number of passes of 4. Multiply all that by 16.3 and we get 1,304 compacted cubic yards per hour. Okay, so now comes the volume part. So we need to find the total volume here. Okay, and since it's the perimeter that we need, we're going to take basically the entire site and subtract out that excavation site. So the entire is this 440 yards by 300 yards. And remember, this comes from here, 440 by 300 is the entire site. So we're going to take that, we're going to subtract the 100 yard by 120 yard. Doing that, we get oh, and sorry, we got this right here is our width and length, and we still need to do our depth. Our depth, if you remember, was 6 inches, or we'll call it half a foot, 0.5 feet, and then everything here you can see is in yards. So we need to divide by 3 feet in 1 yard, and we're going to end up with 20,000 CCY. Okay, so the time then, as we've done before, is just going to be that total volume over the production. So time equals volume over production. And we just found our volume is 20,000 CCY. We got our production up there of 1,304 CCY per hour. And that gives us 15.34 hours, which we can round to 16 hours. And on this one, remember, we only have 1. So on the other problems, we were dividing everything by 3 because we had 3 dozers. But this one, we only have 1 smooth drum vibratory roller. So 16 hours is going to be our time. That's our solution. And then our cost, again, knowing the cost per operator per hour is, from previous problems, is $40.59 per hour operator. Our cost is going to be equal to the number of hours, 16 hours, times $40.59 per hour operator. And in this case, we only have 1 operator. So that gives us a $623 operation. And there's the solution for that one.